Morning, B group. Nope, just kidding. B group's here. A group is there.
We don't get a good morning?
Yeah.
I already said good morning to you. Maybe I didn't say good morning because the first thing that happened when I walked in this room was, can you make sure that the video is not blurry this time?
You're looking
I'm looking directly at you. Yes. So it's not blurry, I'm looking at it. It's really bright today. I don't know why it's so bright. Okay, I did have a question. I'm coming over my computer for a second because somebody said, are you going to post the notes? The notes are already posted. So, if you go to the Googler Classroom. Oh, I don't have my thing in. I hope you can hear me. I have to yell. See, I forgot to put my mic on. Hang on.
It's like a stream though, so if you scroll down like one or two, page 3 is on.
It's in. Okay, hopefully that will make you hear me a little better. So, people in class, please be quiet so they can hear. So, when you go to the Google Classroom, all of your work is on the class stream. In the classwork section. If you go to the stream, here is your schedule for this chapter. There is also a PowerPoint there. There is our study guide. There's a study guide, and there's also the vocabulary list. So you'll notice today is 2:15. Today we are working on slides 29 to 36. Tomorrow everybody's on the line, so you will be completing your chapter 2 notes online. And then when you come in on Thursday, I'm going to check your notes. It's worth 10 points. And also there is a vocabulary quiz. B group, I'll check your notes on Friday. And also B group, on Friday you have a vocabulary quiz. So what is that vocabulary quiz? You can just click on the link. Here you see your vocabulary list. You will come in on Thursday or Friday morning. I will give you a blank half sheet of paper. And I'm going to say, number 1, what does co mean? And you would write together. And then I'll say 2, what does valent mean? And you would tell me strength. The stuff that's in parentheses you do not need to know for your quiz. That's just an example of how we use it. Any questions on that vocab quiz? Okay. So then, let's see here. On Friday, after your vocab quiz, B group, and I check your stuff, we will review for your test. A group, your test is Monday. B group, you'll do your chapter 2 homework, and then opposite on B day on the 22nd. That's all. Any questions? Okay. So while I'm over here, I wanted to go ahead and look at this thing again. So this was a picture that we had and on the blurry video from yesterday. This is showing a reaction. So the things that are reacting, we call them reactants. And here we have the man and the boulder. And it goes up the hill and the reaction occurs, and then these are the products. Okay. So this man, in order for this reaction to occur, this guy and the reactants have to overcome an energy barrier. They have to overcome this much energy before the reaction can occur. An enzyme, which is a type of a catalyst, comes along and it lowers how much energy has to be put into that system for the reaction to occur. What's the thing I drew yesterday? A what? A bulldozer. Right. So we'll draw that bulldozer again. Whoop, just a quick version. Today it's just an automated one. There's no dude driving it. Although I did draw a good dude yesterday. So this bulldozer comes along, and what does the bulldozer do? Does the bulldozer get the guy? No. Does the bulldozer mess with the boulder? No. The only thing that bulldozer is there for is to lower the hill. So it would lower the hill to here. So then this guy only has to push the boulder to here. And then the reaction still occurs. Does anything change about the guy? No. Does anything change about the boulder? No. Does anything change about the products? No. Everything is still the same. The only thing that changes is how much energy he had to put into that system. That's what a catalyst does. And this bulldozer is the catalyst.
Wouldn't there be a lot less speed going down that?
Yeah, because the hill is
Okay,
bigger.
so
And then,
yeah, so that's where the analogy does break down, just because it's a boulder, and in like actually having a reaction, it would still occur the same. but yes, you are correct, maybe.
It's still gonna roll down the hill.
Well, yeah.
Still, the reaction still occurs. I understand what you're saying about the boulder, and it like not, because it's not going as quickly, maybe you wouldn't do the exact same thing, but
Yeah, the products might not be as small as it would be.
they might not be. But in the case, that's where it's just a picture. So that's where it becomes like not true. Yes. Hey, person in you, let's get your head up.
I'm holding my tag. It's digging into my back.
Well, your eyeballs being closed isn't holding up your tag.
I'm thinking.
Yeah. Any questions about this? We will spend an entire day talking about enzymes in chapter 3. I am very disappointed that not more of you knew that that was a bulldozer. Because that was a, huh?
Use scissors.
Bro, it looks like Squidward.
What?
Use scissors.
I do have scissors. Sorry. Okay, scissors-y. Because.
Is there a space shuttle?
Space shuttle?
That's the awkward space shuttle.
Because
Looks like Squidward.
you do need to know this stuff. Oh, you asked. I thought you asked.
I did,
You can
but
cut it
it's
out.
for her.
Yeah.
Okay.
I wish we had these things.
Like all of it or just this pokey
All of
part?
it.
Okay.
Just run out all of it.
Those of you who are at home,
I
I
would've-
would have tagged. Oh my god, I need to get that hair. That's okay, it's just in the back. It's no worries. It's good. Just kidding, I didn't cut too much of her hair.
Oh, okay.
Too much.
Ah, fun times. Okay, so watch the videos.
No.
Watch the
Okay.
videos.
Next shot.
I even have to watch a video.
You
Kid
still
fun.
have to take the keystones. It's still all the same information. You have to watch a video. I forgot this dress has pockets. That makes me happy. Dresses with pockets.
That's weird.
It's not weird. It's one of those things that dudes don't have to worry about because like all of your clothes pretty much have pockets in them, right?
Not
Yeah.
girl pants.
Not girl pants. I wore pants yesterday and the pockets were like this big. Like nothing fits in those pockets. They're just decorative pockets. What was that?
Change.
Yeah, like change. Maybe chapstick. Yeah. So if you've got a good pocket, you can't see. Ugh, I got a whole big pocket here. It's a good pocket. So, I didn't get my. Yeah. It's a problem.
My pocket has a pocket inside.
Your pocket has a pocket?
Yeah.
Yeah.
Pocket has a pocket.
This is.
Who's needs dress coded? Let me see. Stand out of the way. Let's see.
Oh, she's really not.
No, I think his shorts are long enough.
Kevin.
What?
All right, yesterday we left off talking about polar and non-polar. So I said, and I drew this yesterday, but you didn't watch the video. If I have a cookie, and I cut it like this. I said a pumpkin chocolate chip cookie because I really love pumpkin chocolate chip cookies. And my one class was like, ew, that's so disgusting. How about pumpkin chocolate chip? Raise your hand if you like the old pumpkin chocolate chip cookies.
I didn't even know.
First you like sniffing baby's head, now you like these cookies that I've never even heard of.
My
Yeah,
mom.
exactly. It's fire. She
makes
makes
some
it
good ones.
What? She's
Well, with him, I can't say his name on the line, but that dude and I, we are going to be sharing a chocolate chip pumpkin cookie.
Where do you
Pumpkin
get them,
chocolate.
or do you just make them?
My mother makes them.
No, okay,
They're my
that's probably
kid's
why
favorite.
I've never had them.
Yeah. Well, you know what? Mama Shar loves to bake for people, so as soon as I tell her that you guys have never had pumpkin
Oh my
chocolate chip
God.
cookies, she will probably bake some.
I've never had it.
I will tell her. I'm going to see her tonight.
I'm going to
I'll
nickname
tell her.
him.
All right, so I have this cookie, this pumpkin chocolate chip cookie, and him and I are sharing it. Are we sharing this cookie?
Yeah, you
Are we sharing the cookie equally?
No.
Yeah, just cut it in half.
it's right in half.
Ben!
Yep.
Oh, on the line, people. Oh, you can't see me. There you go. Now, he and I are sharing this cookie. What if I break it here? Are we still sharing the cookie?
Yeah, it's not.
Yeah. Are we sharing it equally? No, we are not sharing it equally. That's what happens in a covalent bond. Sometimes the atoms share the electrons equally. We call that nonpolar. Sometimes they share. Oh, back up. Sometimes they share it equally. Yeah, we call that nonpolar. Sometimes they share it unequally. We call that polar. Whenever it is sharing it, so this is nonpolar, in your notes, you might want to write this down because we will revisit this over and over and over again. So that's nonpolar covalent. Here we have a polar covalent bond. And in here, because the atoms are sharing the electrons equally, there's no charge. So nothing, no positive side, no negative charge. Everybody shares everything equally. It's like methane here. So methane has carbon with the 4 hydrogens. Everybody shares everything equally, the end. In a polar covalent bond, one of those atoms is holding on tighter to the electrons than the other one is. So in the case of water, which I didn't stick up there yet, in the case of water, oxygen is holding on a little tighter to those electrons, and it gives it a partial negative side. And the side that doesn't hold on as tightly to the electrons has a partial positive side. Come back. Whoop. There we go. So we're still sharing, just sharing unequally. And then we talked about things that are polar dissolve other polar things. So something that's nonpolar, those are all of our lipids. The lipids are oils, fats, steroids, waxes. Does oil dissolve in water?
No.
Does wax dissolve in water?
No.
No, they don't. So even hot water? No, it doesn't. Because they're non-polar and they can't be dissolved in the thing that's polar. Water is polar. Can sugar be dissolved in water?
Yeah.
Yes. Sugar is polar, water is polar. Sugar can be dissolved in water. My science boyfriend has a video if anybody wants to watch about
I
him.
wanna watch your boyfriend.
So within a water molecule, within one water molecule, where I have, I'll draw it over here. Okay. Beep, 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 beep. Guess what's happening tomorrow? Tomorrow they're getting rid of my Promethean board and they're going to put in a big TV like in Mr. Cochran's room.
What?
I know, the custodians came and asked me yesterday if I needed my screen, and I was like, yes, I need my screen today. But yeah. See it? Okay, so when I have my oxygen and my 2 hydrogens, we said that there is like a slightly positive charge here, slightly negative charge here. This bond between the oxygens and the hydrogens, this bond is a polar covalent bond. That. Whenever I want to put in another water molecule, I would draw another oxygen and my hydrogens. What is the type of bond between water molecules? Anybody remember? From Mrs. Cox's class?
No.
Or from the board? It's not there, never mind, just kidding. Hydrogen!
It's hydrogen.
Hydrogen bonds. There's like a 97% chance that on your vocabulary quiz on Thursday or Friday, I'm going to say what type of bond is formed between water molecules, and you're going to need to tell me a hydrogen bond. Beep, beep, beep. Maybe. Got it. Okay. There it is. So, the bond within a water molecule, the bond within the oxygens and the hydrogens, we call that a polar covalent bond. However, the bond between water molecules is called a hydrogen bond. And because of that hydrogen bond, it's going to allow water to do things that other stuff doesn't do. And we only find hydrogen bonds between water molecules and between molecules of DNA. Before we talk more about like the different characteristics of water, I'm gonna draw DNA. So sorry, you guys are just moving everywhere today. So if I were drawing DNA, I would draw. It is made. How much you want to bet I'm gonna drop it? I need a setup like Mr. Pratt's setup. So, chair, if I am drawing water, I'm sorry, DNA. DNA is a phosphate and then a sugar, and then hanging off of it, it has a nitrogenous base. And then, why am I hearing talking? I shouldn't be hearing any talking. A sugar, a phosphate, and then a nitrogenous base. Okay, then you'd have a sugar, you know how to draw, and then a phosphate, and then a nitrogenous base. Okay, how many strands is DNA? Two strands. So on the opposite side, and it would actually go, there would be a sugar, then a phosphate, then a nitrogenous base. What is that? Somebody ringing?
No.
That's okay if you're ringing. I'm not going to take your phone. That
I
might be
think
true.
we're running things.
No.
What'd you say? Did you say I'm getting old and hearing things?
Well, obviously, I didn't say that.
I'm the teacher. It was not you. I know it was you. That's why I don't like these masks, and I don't quite know your voices yet, so I don't know who to yell
I
at.
have multiple
You know
voices,
what?
so you'll never know.
Kevin, you'll know.
Yeah, I'll take it.
Between here, this is a hydrogen bond. This is a hydrogen bond. This is a hydrogen bond. And then we've got our hydrogen bond there. So here's my question. Well, I gotta give you some background information. We have, inside of every cell, you have your DNA. And it's 2 strands. And we want those 2 strands of DNA to be able to separate because we need to make new copies of it whenever we're, like our cells are dividing. And then we also need it to separate so that we can produce the proteins that give you the characteristics that you have. Water. Does water separate easily?
No.
Like the different molecule from molecule.
No. Yeah.
What do I have in my cup?
Water.
Water and
Hot chocolate.
ice. And if you look at the top, there's condensation. So I have all 3 states of matter right here in my cup. Did I have to do anything for that?
No.
No, it happens pretty easily, right? So here's my question. Does it seem then like hydrogen bonds are strong bonds or weak bonds?
Strong.
They're weak.
Weak.
Hydrogen bonds are actually a very weak type of bond, and we want them to be kind of weak because we want the water molecules to be able to separate so that it can pretty easily go from a solid to a liquid to a gas, and so your DNA can separate. So they are not as strong as a covalent bond. Because of this water, and if it's not in your notes already, make sure that you do write down and between DNA molecules, because those are the 2 places that you do find the hydrogen bonds between water molecules and between molecules of DNA. So those hydrogen bonds, it gives water its unique characteristics, such as, let's see what the first one was, cohesion. And what do we say co means?
Together.
Together. See, we're going to use these words all the time. I love the vocabulary quizzes. It's also super easy for you. Usually, in years past, I have made the bonus question on your vocabulary quizzes, is your book covered and in class? I'm not going to make that your quiz question now because I don't want you to have to take your books home and back and home and back. Okay? So if I told your class that at the beginning of the year, I'm not doing that question. Co means together. So water is holding on to other water molecules. This should hopefully just be a review from Mrs. Cox's class. When it's holding on to those other ones, it creates surface tension. So that's what's going to make this water strider be able to run on the water. It's going to make this lizard be able to walk on the water. I think they call it the Jesus lizard. And it's, yeah, this.
That sounds hard.
Do you remember doing this in Mrs. Cox's class? It's going to be weird. I'm not going to have a projector that has this light here. I should make hand puppets while I can. Wait, why can I not figure out how to make hand puppets? Oh, because no. Can't do it. Can't figure it out.
Crooked owl.
I know, but I'm like, oh, there it is. I'm like, why can I not see it? Because I can't see it on here, but I can see it here. Whoop. Wait. Whoop, 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 whoop. What?
Huh?
What about Mr. Rob watched this class?
No. Nothing.
Yeah, it got real bad. I got real bad in my AP bio class the other day because they were like doing work down there, and they were on the ball field weed whacking, and they were mowing, and he mows so fast, and it looks like it's so much fun. And then they had a dump truck and a backhoe down there, and I just couldn't concentrate because there was all kind of work being done.
So you're like me.
Yes. My neighbor actually just texted me this morning, and she's having some pine trees cut down. And she's like, I'm just watching the pine trees. So I was sitting in my house watching the men work. And I saw on the Facebook that my other neighbor was like, him and his son were sitting on the porch watching. So there's like super exciting things happening at my house right now. They're cutting down pine trees. Yeah. Exciting. Is it mask break yet? Not yet. We still have another couple minutes. Do you remember doing this in Mrs. Cox's class?
No.
The water on the pennies?
No. Yeah.
Yeah? Okay.
Yeah.
So you took those pennies and you put droplets of water on it, and what happened?
You
They
kept
stuck
going
together.
up until it was ball.
They stuck together, right, because water is cohesive. Co means together. The water stuck together, and you kept putting the drops on, and it formed that kind of like little bubble thingy at the top. Can you see it?
Oh, that's a penny.
It's a penny with water. Yeah. And then eventually it was too many drops of water, correct? And then it overflowed.
We had to see how many drops.
Dang, I thought that was like
Yes.
a slipping mouth.
And you were looking at surface tension.
I thought it was a rock.
That's different than what is called adhesion. On adhesion, the water is going to hold on to something else. That surface tension is also the thing. Hang on, let me go back here. Why like you can't like jump off of like a belly flop. Okay, so you like do a belly flop and you hit. Well, that's why it hurts, because you're not breaking that surface tension.
You don't have enough fat on your stomach to.
No, because it's all hitting at once. So that's why. So if you like threw in a rock and then did a belly flop, then it wouldn't be quite as bad. It's also, if you've ever done any type of martial arts, like if you like fall, you like slap the ground.
Yes.
Yeah, you've never done that? Yeah, like if you're like, yeah.
That's that theory out.
Not right now, not on the hard floor. Do it like on a mat.
Like me.
Yeah, but if you're falling and you hit the ground, if you slap the ground, then it kind of like displaces the energy. Do you do the martial arts? I didn't know that. Hapkido? Nice.
Yeah, I almost killed a
Really?
Supposedly, I don't remember, but I almost killed a kid because
You did.
no, seriously, that was what I was watching one of my matches and I supposedly killed a kid because I
That's
thought I almost killed a kid because I knocked the wind out of it.
Which one?
Huh.
And then I got the wind knocked out of me and then I quit
No,
because
you're, no, you did.
I swear to God, I have the belt in there.
He will tell you to go.
Okay.
Yellow belt, that's-
Mass break. That's
On
interesting.
God.
But that really is a thing. That's really a thing. Whenever you're doing it, you like hit the ground, it displaces the energy. Same thing with surface tension.
Broke his arm.
I think
What?
I think I went to yellow green.
Oh, geez.
I didn't do it for long.
That is different up here. We're not done. Just because it's mass break doesn't mean it's talk break. I can't see. I have a hair in my eye. There it is. Okay.
That's like the worst.
Adhesion. In adhesion, that is where water holds onto something else, like the inside of a straw. So whenever you are drinking out of a straw, it's a little bit of both. So the water is going to hold on to other water. That's cohesion. It helps pull it up. It's also holding on to the inside of the straw. And it produces what's called capillary action. So, and I don't think you've ever done this one. And every year I forget until I look at this slide that I want to do it. But if you take colored water and you put like celery in it, because of capillary action, because the celery is still pulling some water, it's going to make this celery turn different colors. So it'll make it turn blue or red or like dark green, not the color of green it is.
So it's pretty
You
much
should do
dying the
that.
celery.
Yes,
You should bring some in. when
Yeah, we
do
should
I
try.
should. Maybe I will.
that.
You can do it with flowers. You do it with flowers often because like flowers don't,
So it's pretty much tied
Have that.
then.
kinda, but from the bottom. But you know, even if you tie dye, or say I have water, and then I'm gonna spill some water right now. So if I have water here, and then I just place my paper towel in it, it's going to eventually climb up the paper towel, right? Like it starts to soak it up. These paper towels don't do it so quickly, but that's capillary action there. It's moving its way up now. So my paper towel is now wet on the bottom all the way because of capillary action. Now I have a mess.
No
that's what's happening here. Those are what are called capillary tubes. Sometimes we use those. Heat. It takes a lot of energy to change the temperature of water. So there has to be a lot of energy that goes into it that's going to cause it to transfer. So, oh, that's not the slide that's there. Heat, how much energy is in something, temperature is the intensity of that. So specific heat is the one that is going to measure how much energy has to be put in to change the substance by 1 degree. So water has what's called a high specific heat. It's a bit chilly out there today. So if you went past somebody who has a pool or a creek or the river or whatever, and you saw that steam coming off of it, right? Mm-hmm. That is what we call, well, it's just evaporation, right? So it's like warm. It's releasing heat energy. If you have a pool and you don't have a solar cover on it, you can still swim for a while, right? Like it'll still stay warm for a little bit because it takes a lot of cool mornings like today before it's going to actually change the temperature of that water. But it also works the other way. So in the summer, so say you open your pool, I don't know, May. So say you open it, we'll say Memorial Day weekend. If you don't have like a heater in that pool, it's gonna take a lot of really warm days. So it's not gonna be super warm to swim in there until what, mid-June, maybe July, before it starts to be like warm enough. It takes a lot of energy to change the temperature of water. And that's kind of good. Because what are you made out of a lot?
Water.
Energy.
Water? So we don't want you to just be vaporizing. Wouldn't that be awesome? Yeah. Because of water's high specific heat, water can exist in all 3 phases on Earth. It can exist in all 3 phases right here in my cup. It's super easy for it to exist in all 3 phases. I need a refill, it's almost empty. Excuse me. We know that you can freeze, liquid to a solid, thawing, solid to a liquid, evaporation, liquid to gas, sublimation is a solid to gas. That one we don't see as often, but we can see it. So with water having a high specific heat, it's important because lakes and oceans are able to stabilize air temperature. I don't know why that's circled. It's just the map that I pulled up. So here's the map of the United States. Well, it's the world. And when we're looking at this, you will notice that, say we're like here, our temperature here, even though we're at the same, oh, what are those lines called that go this direction? Is that latitude or longitude? Latitude, so here's latitude. Even though we have the same latitude as somebody maybe like here along the coast, our temperature always tends to be a little bit cooler than theirs, right? And if we have snow, they don't get as much snow as we get, just because this large body of water called the Atlantic Ocean kind of regulates that temperature. It's going to make it a little warmer. In the Atlantic, the way that the water flow goes, it kind of goes like this. Okay, so when you get to like the Caribbean Sea and you get up into the Gulf of Mexico and up through the Atlantic, it's kind of warm, like the water's warm, right? As opposed to if you were going across here to California, the water in the Pacific is always kind of cold. Why is it cold? Because it comes this direction. So it goes up past like Russia and not China. Yeah, I guess China's over there too. Alaska, and then it comes down here, so it's still a little chilly. Anybody been to the Pacific Ocean? Okay, it's cold. My friend lives in Portland. We went to the beach one time in Portland, and even though it was July, it wasn't like beach weather. Like you could wear a swimsuit, but it was kind of cold. And if you got in the water, it was really super cold. Why do they have to do things down there? Because then I just get distracted. But they took a van, so it's probably nothing super exciting.
They're going to pick up the children.
Also, this is super important. We're going to talk about ice and why water, like solid water, floats tomorrow. Excuse me. Make sure you watch that video, the group who were in front of me. Make sure you do watch that video tomorrow because that will be an important one. But whenever water freezes, it's going to float. So when that water floats, so now we have ice on top of like a lake or a river or a pond, it's going to help insulate the rest of the pond so that the little baby fishies don't die.
But we died. Yeah.
I'll just look at this. Solid water is less dense. I do have more time than I thought. I forget that that clock is off. So that clock says, from my angle, it looks like it's 9:30. For real, we still have like 7 minutes, so that's awesome. When everything on the planet freezes, so everything on the planet, when it goes from a solid state into a liquid state, opposite. When it goes from a liquid state into a solid state, so it's liquid, the molecules are here, and then it gets into a solid state, and the molecules go closer together. And yesterday we looked at how those molecules, in something as a solid, they just kind of hold on really tight to each other and they vibrate back and forth. Everything on the planet does that except for water. Stop packing up, look up here. When water freezes, the space between the water molecules expands, it gets bigger. The water molecules do not change in size. The water molecules stay the same. The only thing, and you can see it here, so here they are in liquid, here they are as a solid. The only thing that happens is the space between the water molecules expands. They will ask this question on the keystones. So the space between the water molecules expands. That causes the solid water, or the ice as we call it, to float. So if I were to say, why does solid water float? If you tell me because it's less dense than liquid water, I'm going to say no. I'm going to just mark it wrong. It's true, it's a great 5th grade answer, but for here, it's because the space between the water molecules expands. The molecules themselves do not get any bigger. The space in between them expands. Normally, in a non-pandemic year, I would make 3 of you come up here and hold hands, and we would look at what those molecules look like. But we cannot do that right now because there's a global pandemic. So, we won't, but I'll try to figure out something to do for Friday for your class. It's also why, say if I had a bottle of water, I don't have a bottle of water on me now, but say I took a bottle of water and I put it, and it's full and it's sealed, and I put it into the freezer. What happens? It freezes. What's probably going to happen to that bottle? It's probably going to it might burst open, right? Because that often happens. Because whenever that bottle of water freezes, the space between the molecules expands. There's not enough room inside of that bottle for the frozen water, and it breaks. Kind of like if you put pop into the fridge. If you put a can of soda into the fridge, it's going to, because it's mainly water, it's going to freeze and it'll break the can because there's not enough room inside of that can for that frozen water. Again, super important. The size of the molecules does not change. It's the space between the molecules that changes. Everybody got that? Okay. So that is where we're going to leave off for today. A group, I will see you tomorrow. Nope, I won't see you tomorrow. Everybody is online tomorrow. Everybody is filling in their chapter 2 notes, and I will check everybody's notes on the next day that you're here, and also on the next day that you're here, you have a vocabulary quiz. Any questions? Okay. Have a great day.